virtualizing failover cluster instances and availability groups. And of course, with the title of Virtualize FCI and AGs, expect a lot of acronyms. I had some feedback once from one person who attended the session in SQL Saturday event and said, you're using too many acronyms. And unfortunately, there are a lot of acronyms here, and I will try to define most of them as I go along, but some I'm still hoping you know. All right, so first about me, I am Sean Myers. I am a principal architect and practice lead for a company called House of Brick. I have a lot of experience in VMware, in Microsoft SQL Server, so I try to act as a translator between the DBAs and the virtualization folks. I've been working with SQL Server since 6.5, and started in 96. And I speak at many different events, including the PASS Summit for the past 2 years, VMworld for the past 3 years, and many SQL Saturdays and local user groups and virtual chapter meetings. If you want me to talk to a local user group you're involved in remotely, let me know. I can do that as well. The company I work for is called House of Brick Technologies. So House of Brick is a small consulting firm based in Omaha, Nebraska. We focus on Oracle and SQL Server around license optimization and virtualizing your business critical applications. How to put your high-end, your largest databases in a virtual platform, whether that be on-prem or in the cloud. We'll work with you. Plus, we do a lot of replatforming, migration from Oracle to SQL Server, license optimization, and just HA&DR. So today, what we're going to talk about is why using failover cluster instances, the VMware settings you should know, storage options, and one of the biggest areas where you struggle with failover cluster instances specifically, and sometimes availability groups, is in the storage layer. Then we're going to talk about always on and some DR considerations as well. So first of all, I'm going to cover mostly VMware, but talk a little bit about Hyper-V. I focus mostly on VMware, so I know a lot more about their stack than I do about Hyper-V. And Hyper-V actually for failover cluster instances just works much easier, so there's actually a lot less to cover. I'm not going to discuss how to go build a Windows Server failover cluster or a failover cluster instance or an availability group. I'm going to talk about how these impacts when you run virtual, what's going to be different about it, versus having these things run when they're physical. But if you have questions about those specific things, feel free to contact me and reach out. I'll try to answer best I can. So this presentation is designed to be about 50 minutes. And when I'm talking to an audience with a lot of feedback, I tend to talk a little bit slower. At times I might start going a little bit too fast or get excited or skip things here since I don't have any feedback from the audience as we go. So please go ahead and feel free to ask questions to make sure I stop and slow down and clarify anything that I may have just gone by too fast. I like questions and it helps me make sure we fill up the whole time and you get the most out of it. So terminology. Couple things. First of all, there's always space on and always on. What's the difference? You know what? For a while, it was always no space on was the technology term that Microsoft used. Then now, actually in 2016, they call it always space on. They can't keep their different this acronym or this saying what they want to use for it. If you look at the documentation, you'll see it listed both ways. There's no right or wrong answer anymore. Always space on is the correct methodology today going forward. However, you'll see docs both ways. I tend to use the always no space on still because I learn and I don't change habits quickly. The next thing about this, always on is also now a marketing term. When I say a marketing term, it is not a technology specific because you can do an always on in Exchange, you can do always on in SharePoint now, and you can do always on as an FCI or an availability groups. Both of those are actually all under the always on umbrella. So if someone says, I've got an always on SQL system, I go, okay, is that an FCI or an AG? They usually mean an availability group, but just using proper terminology. Cluster. Cluster is a term that even I use and I stumble over. Cluster needs to be dropped from our vocabulary to some extent because there's Windows clustering, there's Hyper-V clustering, there's VMware clustering, and then the failover cluster instance in SQL Server is also what people call a SQL Server cluster. And since there's so many different things this can mean, we got to stop using the word cluster and be more specific about what we're talking about. When I'm talking about clustering, usually I'm referring to Windows clustering and the underlying features of that, which is what the SQL Server failover cluster instance and Windows availability group both rely on. Next bullet point, the WSFC, Windows failover. I have the acronym wrong. It's Windows Failover Cluster Services, and I have WSFC. I'll go fix my deck here pretty soon before I send it out to anybody. FCI, Failover Cluster Instance. AG refers to availability groups. So far, everything I've seen with availability groups, the basic availability groups, which is a new feature in Standard Edition in 2016 and on, works the same. There are some obviously differences in how they work, but from a virtualization standpoint, there's no difference. SQL, structured query language, which we all like to program in T-SQL, versus SQL Server, which is the Microsoft database platform. And why I talk about that is many people will say SQL and assume you're talking about SQL Server. I work in an Oracle shop, I have a lot of Oracle folks and some DB2 and MySQL. All those are SQL database systems. So when I say just as a SQL database, it could be an Oracle database or a DB2. Doesn't necessarily mean versus saying SQL Server, we're being specific about the product. I know it's kind of semantics, but it's one of the things we do need to care and worry about. All right, so the first thing, via failover cluster instances versus VMware HA. In other words, I like to keep things simple as possible. I only use failover cluster instances when I have, in this case, less than 4 minutes of mean time to recovery. Also, if I'm using rolling patching, I have a cluster-aware middle tier, and do I have expertise? So what this means is if I can handle I say 4 minutes, that's the outside. A lot of times it's 2 to 2.5 minutes of a failover. If I use basically native VMware HA or Hyper-V high availability functions, it will reboot my VM if it crashes in about 2 to 2.5 minutes. 4 minutes on the outside, depends upon how many databases you have and how big TimDB is and what things it has to clean up from your redo and undo kind of stuff. But 2 to 2.5 minutes is a good time. If your system has an SLA that can support that, let's not do clustering. Because if I don't need to do any kind of failover cluster instance or an availability group from an HA perspective, I've made the system much simpler. The other thing, of course, when you use HA or VMware HA or Hyper-V's HA, you don't actually have rolling patching anymore. So some people really require that because they cannot schedule maintenance windows. If you can schedule maintenance windows and you can do your patching after hours or whenever it's non-critical time for business, again, let's see if we can go make it simpler. Cluster-aware middle tier. I rarely see the application or the middle tier actually cluster-aware. Very few things can actually handle a cluster failover without a drop and retry process. The applications themselves just aren't coded for it. Do they still work? Yes. All it means is they get an error and they have to retry. By the time they retry, it works the second time. And then, of course, expertise. I find anybody can build a failover cluster instance or an availability group. But when things go bump, can anybody fix them? That's the issue because there's so many different facets of it. You have the AD component, the Active Directory, where you deal with your Kubernetes specifications and your DNS records, filing back and forth in the right permissions, and your computer accounts. Those have to be set right. A lot of times I run into, when I see errors, it's in that area. And then, of course, there's a storage component to it. There's the Windows failover clustering system, components to it. Then there's how SQL Server sits on top of that, and all these different facets. You have to understand all of them together to help troubleshoot. And if your organization does not have a deep level of understanding in some of these areas, troubleshooting can be very tricky. So if you don't have that expertise, you either need to develop it or see if you can avoid using them. So let's talk through the different HA options we have here. Well, first of all, HA really isn't HA. The truly high availability means I'm going to prevent my workload from ever going down. So I am going to have multiple power supplies. I'm going to have my disks on RAID systems somewhere. They're not on a JBOD kind of things. I am trying to prevent the system from ever going down. All these technology, VMware HA, failover cluster instances, and availability groups are actually really fast recovery. System went down, it failed over, it came back up. So we actually did have an outage. So it's not really highly available now. We had a very short outage window. But everyone calls it HA, so I'm still going to call it HA2. So multiple areas to consider. What we're here is this chart is I'm going to compare VMware HA, Hyper-V's HA, failover cluster instances and availability groups, and a VMware's technology called fault tolerance. You notice there's an asterisk on fault tolerance. The asterisk basically is you need to be on vSphere 6 and above, which has been out for about 2 years now. So many organizations are there, but many of them are not still. There's also some limitations. So I look at this, I look at each of the Limits on things, i.e. hardware failure. How fast will each one of these recover if in an event of a hardware failure? VMware HA and Hyper-V basically will all come back up in like 2.5 minutes, 4 minutes on the outside. I like to publish the absolute long time. The failover cluster instance, tends to be about 30 seconds to 3 minutes, depends upon a number of configuration issues. I actually have one client that has a failover cluster instance with 16,000 databases on it. I don't know if they're trying to set a record or what. The problem, of course, is because you have to go through redo for all 16,000 databases, it takes it well over 1 hour on a planned failover. So their HA process isn't all that great. They have a failover cluster instance that can't really fail over, and they can't use it for rolling patching, but they still do. So that 3 minutes, the 30 seconds is a kind of a round number. If you're tuned it properly, you should get about 30 seconds to 45 seconds from the time you have a hardware failure to the time your system is working up on the other node. Availability groups, I've seen people get it down as low as 15 seconds, on a detection and failover. There are multiple facets involved regarding how the heartbeat process is set up and how fast it can fail over. I like to quote 30 seconds as a fairly good number because it fails over faster because the databases are already online versus in a failover cluster instance, you have to start up the SQL Server services and bring the databases online, through the whole redo and undo process to make sure the logs are clean before you do that. And then VMware fault tolerance. It has no hardware failure problems, meaning if you actually lose a machine, the transaction will complete on a different machine. What it is, you're doing a lockstep technology, so everything's going on, happens on one server, goes and happens on the other server. So they happen in sync with no issues. So if you actually have a hardware failure, VMware fault tolerance actually, in my mind, is an HA solution because it actually did complete the transaction for you with no outage. All right, rolling patching. Many people like to use rolling patching so they can minimize the amount of impact. So I can be patching the non-active node and then roll over, finish the patching, do a failover, and then patch the other node, which is now non-active. So that way I can have the most amount of uptime with the least amount of downtimes. I have a 30-second failover in between, but that's okay. That's it. So VMware HA and Hyper-V, their HA solutions, does not offer rolling patching. Availability groups and FCIs do offer rolling patching, and fault tolerance does not. OS corruption protection. I put this on there because I used to say, well, how often do we have OS corruption issues anymore? And then I go to a client site the week after I started at a SQL Saturday, and they showed me 2 instances where they had OS corruption in the past week. I'm like, oh. So I decided to put it back on. This is basically when you're doing a patch or something goes wrong or somehow something just, DLL nightmare issues, and all of a sudden you've got an OS corruption, you went blue screen. So is there 2 copies of the operating system to protect you? With VMware HA and Hyper-V HA, no, there's only one version. The machine moves as it fails over. So there is no protection for your OS side. The failover cluster instance and availability groups both have 2 OSs. So you actually have protection from that perspective. And fault tolerance, even though there are 2 copies of the OS, they're in lockstep. So if you happen to delete a DLL or cause an update to a DLL that causes a corruption issue of some sort, it will actually happen on both OSs at the same time. So the corruption will happen in both cases. So even though there's 2 OSs, you don't actually have protection. Storage redundancy. Do we actually have multiple copies of the data? Some people consider it as a pro, some consider it a con. I.e., one copy of the data means I don't have massive sprawl and scale, and I have, I've optimized my storage. My storage is obviously highly available underneath the covers. I'm on a SAN that's got RAID 10, blah blah blah. It can't go down. Some people still like to have a second copy of my data, just in case. So with VMware HA and Hyper-V HA plus failover cluster instances, no, there's only one copy of your database. So if that one goes corrupt, you have to go restore it. Versus with fault tolerance and availability groups, you now have a second copy. So if something goes wrong with the one copy, you fail over to the secondary, you now have a valid copy. So it has one more area of protection for you. And it really comes down to how much do you trust your storage admins. Complexity. How hard are things to deal with? So I say for VMware HA, the complexity is extremely simple. You have 4 clicks from the time you say, I want to turn it on to the time I'm done configuring it. Just 4 clicks. Boom, 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 boom. I'm done. It might take all of 3 minutes, and anybody who has any VMware background can take care of it. Hyper-V. there is some complexity because the Hyper-V itself is running on a Hyper-V cluster. So I'm setting up clustering technologies underneath the covers to make the Hyper-V process work for the HA. Once I've built the Hyper-V cluster, the HA process is kind of baked into it. So I say it's a medium because there's a lot more to worry about. Failover cluster instances, I consider them fairly complex. They're one of the more complex configurations you have in SQL Server because there's, again, there's the SQL Server installation rides on top of failover, rides over on top of the Windows clustering technologies and the install process. Same thing with availability groups. Availability groups, to me, are even more complex because now it's not an instance level. I now have a per database level things to worry about. So now I have to keep my things in sync. How do I keep my jobs, my users, and that kind of stuff in sync? And then VMware fault tolerance. It's actually even simpler. You just right-click on the VM and say, enable fault tolerance, choose the location, and click OK. It's 3 clicks. Limits. I say limits for none of these except for VMware fault tolerance. As of today, it's only available for virtual machines that only have 4 vCPUs or 4 cores. Most tier 1 workloads are much, much bigger than 4 cores, and you can't use it for that. So this is great for tier 2 things or small workloads, but it's not great for most things, which is why most people don't use it. I'm just using it here for our comparison. And the other thing about it, of course, is when you're using VMware fault tolerance, it will double your licensing cost for SQL Server because the second node is actually operational and running, which means it's considered by Microsoft a licensed copy. Until Hyper-V offers a similar feature as fault tolerance, then I'm sure Microsoft might change their answer on it. But right now, Hyper-V doesn't offer it, so you have to pay extra for it if you use from VMware. As we talked about, I think adding a failover cluster instance when it's virtual, I'm adding another layer, like a layer of complexity to an already complex configuration. If you have the problem of it's not working properly, or my favorite one, it's slow, now I have a virtual layer to deal with too. Is it the virtualization layer adding to my problem? Why can't I get a Kerberos ticket to make sure the system fails over properly? It gives me some AD permissions error. Is the virtual layer involved in that somehow? Probably not, but it's possible. And so now you add another group of people involved in troubleshooting. So you get more finger pointing around going, it's not my fault, it's the storage guy's fault. And we all know the DBA stands for Default Blame Administrator. Now we've got to go another group to go point fingers at and figure out how can we do this work. If your team and your organization works great, this is awesome. But if you work in an office that has lots of silos, this can be very difficult. Another option people understand is you can take a failover cluster instance and mix virtual and physical nodes. I have many clients who use this for how they migrate into the virtual world. Their physical cluster, they just add a virtual machine node to it, add it to the cluster, and then migrate. It's real simple, and that's how they do the migration process. Or sometimes they just have the physical as the primary runs on physical, and they keep the virtual machine version as their primary backup of it. So if it fails over or they're running during patching, they don't have quite as much horsepower on the second node, and they keep those as VMs. It's possible. I already mentioned that at the end of the day, a failover cluster instance is much easier to configure on Hyper-V, mostly because of storage presentation that is on VMware. And right now in VMware, there is a limit of 5 nodes for a failover cluster instance. And for an availability group, there is OS maximums. And for Hyper-V, it's OS limits as well. So you can do your failover clusters as large as you want to with Hyper-V. Quorum. All right, so is there a difference in how your quorum works when you run a virtual machine? No, there is no difference. The quorum disk is the same. It works the same way. You configure it the same way. It's shared storage. The file share witness doesn't require a shared disk for the quorum. It's a file share, and that works just the same way as it does in the physical world. Same thing with node majority. Also doesn't require a shared disk for the quorum. And from a virtualization standpoint on VMware, the shared disk is the caveat process problem of having working clusters working properly in VMware. So if you don't need to do shared disk, it's much easier to do your setup. An availability group with a file share witness does not require shared storage, which makes the setup of an availability group much, much easier. And the failover clustering from Windows is much more difficult to set up than actually the failover cluster instance. All right, storage presentation. This is the different layers of storage and how it's presented to things. So in VMware, you've got on the right, you see 4 things, but I only got 3 sets of bullet points. RDMV is not supported for clustering at all. So if I'm doing my options here, I got a virtual machine disk, which is VMDK/VMFS. VMDK stands for virtual machine disk. VMFS stands for virtual machine file system, I believe. It's been so long since I learned it, I might have forgotten it. You prefer the VMDK is the native version of VMware for storage. It works the best for things. However, it does not work with failover clusters. Failover clustering actually requires a thing called a SCSI reservation. And that is what locks the files on the drive. So node A and node B knows who's in charge of the storage. VMware currently does not support the SCSI reservation processes. I don't know if they're going to. I've heard rumors and I've heard probablys, but I've never heard anything concrete and I haven't seen anything. So to make a failover cluster instance work on VMware, you need to use a thing called an RDM-P. An RDM stands for Raw Device Map. It is a pointer file on the VMware layer to points to the LUN. And so the VMware system does not see the LUNs directly, and it just sort of passes through the commands to the storage layer. So it has all the VMware tools for managing storage are now removed, and which is why your virtualization admins will tend to hate doing RDM-Ps. An RDM-V, which is listed there, allows a lot of the VMware tools to work, and there's actually it's a virtualization layer or a virtual RDM. And then direct mount is direct mount basically, which is also known as guest. So you can use iSCSI or SMB shares and put the stuff right into there, into the guest OS, and the virtualization layer is unaware the storage even exists, much less has any kind of control over it. So at the end of the day, it has the cons on that is no ESX level storage tooling, but vMotion works great. And of course, actually, I have to update this deck too because I wrote this deck multiple years ago. The RDM-P, what says here, the last bullet point says no snapshots or vMotion. In vSphere 6 and above, you can vMotion. I cover that in a later slide too. So if you're going to build a failover cluster instance or an AlwaysOn availability group, this KB on this slide at the bottom is one of the most important KBs out there. However, this is one of the most poorly written KBs you'll see. It's a VMware KB. I know Denny Cherry and Alan Hurt and David Klee and myself and many, many others have all wrote emails to VMware on how to fix and make it more clear. It's gotten much, much better. However, it's still got many, many problems. You'll see it talks about clustering. It says SQL Server clustering. The things you want to look about, we've got shared disk. We want to look at the shared disk section, which is going to basically refer to your FCIs, and your non-shared disk is going to refer to your AlwaysOn availability groups. If they've listed out the different Exchange versions as well. So this covers all Microsoft clustering technologies all in one slide, and they've got different KB for each of the versions of VMware now, which is a good thing because it made it a lot clearer. So you go to the main KB listed here, you actually see you want to go to the 5.5, the 6.0, or the 6.5, and you choose the version you want. The thing you care about is looking at what kind of storage presentation. On the shared disk, it talks about RDMs versus NFS, and it has all kinds of fun stuff. Like you'll see, for example, it says SQL Server clustering under VMFS. There's a yes with a number 3. And if you went to that KB article and go read number 3, it says cluster in a box. What cluster in a box means is both nodes run on the same ESXi host. That's great from getting an FCI to work on VMware. It's bad from in case that host goes down because both nodes went down at the same time. I actually had no HA protection. It's great for dev. It's great for learning. It's great for testing. It is not good for production. So make sure you read through this and read through all the different notes, why number 5, number 1, all those different things and what they all mean. It does take a long time to go read through this, and it's a horribly written KB, and you'll get through it eventually. If you have questions, send me an email, and I'll try to answer as well. So in-guest notes. So when you decide to go with in-guest instead of using an RDM or a VMFS, SQL Server failover clusters don't support NFS yet, and I don't think they ever will. They went with SMB. And SMB only works with 2012 and above. And in 2012, it doesn't work with a failover cluster instance, only direct. In 2014 and above, it works great with SMBs, with failover cluster instances. And if you're trying to run on SMB 2.1, which was part of Windows 2008 R2, it worked okay. But when you went to 2012 and 2012 R2, and now 2016 for the Windows OS, they had SMB 3.02, and then great, vast improvements. Microsoft did a great job of rewriting all the bugs and getting rid of all the problems that was in SMB 1. Then SMB 2.1 had a lot of fixes, and 3, it's now functional. It's actually really, really good. It's really solid, really fast, and it has security. So if you're going to be doing anything with SMB in a SQL Server, I would recommend only being on 3.02 and above, even though you can do it with 2.1. It's not worth the effort and the pain, though. Not to mention, again, if you're trying to run a SQL Server 2014 on a Windows 2008 server, you've got other issues. All right. So also now you can use cluster shared volumes with SQL Server in 2014. Cluster shared volumes are great to use too. It's just a network path now. And iSCSI works as well, has worked for many, many years. Many of you have iSCSI storage. This is a great thing for doing your ingest for setups. Migrating a virtual machine. So VMware calls it vMotion, and Hyper-V calls it live migration. And both work to move an FCI node. SQL Server, or actually vSphere or VMware, says you must be on vSphere 6 or higher. 6.5 is the latest release, so there's actually a new addition for them. It was, what, 18 months ago when they finally allowed this feature. However, though, on any high-performance SQL Server, you want to minimize the movements. You can move them. I don't want you to. The reason why, if you actually go read through how VMware and Hyper-V performs these movements, they do a snapshot with a Delta file, and they do the migration of the memory. And so then they move, when they finish the first migration, they go back and do a second pass and move it again. If they get to the third or fourth pass and the rate of change of data in memory is faster than the migration network, both of them will throttle the CPU to slow down the rate of change to allow the network to catch up. Meaning you can have performance issues when doing a live migration or a vMotion. So you want to minimize those. You know what, on small SQL servers, doesn't matter. You're not having massive rates of change. But if you're on a big SQL server, you're doing some ETL process, or it just happens to have, thousands of transactions going on it, and your migration network, your vMotion, your live migration network isn't robust, you could see some performance issues. And both Microsoft and VMware have decided that completion of the migration is more important than maintaining performance by how their systems operate.
Sean, I've got one question that has come
Sure.
up. Someone's asking, and let you explain what SMB stands for.
Oh, sorry. SMB stands for Server Messaging Block. It's basically the Microsoft answer to what NFS was in the Linux world. It's kind of like a CIF share. So in other words, I can have a server, or even my storage system can offer SMB shares, which is like a file system path on my storage array. And allows the SMB protocol allows for the security and how to multipath to it. I hope that answers the question.
Okay.
SMB has been around in SQL in Windows since NT4, but it was crap for SMB 1, and no one ever used it. And then Microsoft back in 2008 realized they need to use it for a lot of other things and started working on it. Hence, they came out 2.1 in 2008 R2.
Okay. And then someone else has, I would appreciate if you could clarify about the cluster share prior to 2012 and now with AGs. Is it the same mechanism when it fails over from one node to another in AGs?
Is it the same mechanism for when it fails over? I'm not sure the question exactly, but I'm thinking is, so how does it do the detection to do a failover? So an AG and a failover cluster instance both uses the same technology under the covers to do it. They have multiple different things, but there's one called the heartbeat, and then there's one called the health check. The heartbeat basically is more of, are you ping, is it alive? And the health check is actually validates that the SQL server is actually responding properly. There are other checks under the covers as well, but those are the two big ones you see that will cause a failover. And we'll talk a little bit more about those later on. There's a slide near the end that covers that, and we'll hopefully answer your questions in more in depth.
Okay, that's all the questions for now.
All right. All right, so we just finished talking about migrations, and where it says the last bullet point here, migration networks should be dedicated, meaning your virtual machine, your virtual admins should have a different network just set up for the migration of your SQL Server, or not your SQL Server, for migrations of virtual machines. Don't try to do it on the same network with your regular traffic. I see people try to, it's never a good idea. So failover cluster impacts to VMware. VMware admins have a large toolbox for managing environments. So you guys can read this. They have all these great things to deal with their storage in the day. When I do a cluster or a FCI, I am removing a lot of those tools from their toolbox. So I'm limiting what they can do for how they do their work. And they don't like it. So again, you can't vMotion SQL Server cluster nodes or FCI nodes until vSphere 6. With vSphere 6 works fine, but when you do that, all hot add features and drive growths can't occur. So if you're on when you're not using an FCI and you're using a standalone SQL Server, or you're using a availability group and you're running out of drive space, you can go ahead and add drive space and do a growth automatically. When you're doing a RDMP or if you're doing a vSphere, if you're doing an RDMP, you cannot add drives while hot. You actually have to take the drive offline to do that, which is annoying. So you're planning your growth, you have to make sure you size things correctly versus on other virtual machines, you can size on the fly. Now, RDMP prevents storage vMotions, so you can't balance storage. The VMware has lots of great tools for, we have storage hotspots here. We have too many VMs using the same piece of storage, same disks. Look, we've done some testing and found this one section, these ones over here have much less load on it. Let's automatically rebalance and move some workloads there. Your FCIs configuration will prevent the VMware admin's tools from automatically balancing workloads. Also not compatible with snapshots. So if you're doing a snapshot for patching and rollback, you can still do them. You're only going to snapshot the OS drives, not the data drives. So if you do rollbacks, your rollbacks are going to be a little more interesting because you're going to have any data changes will still be there. So you got to understand the rules behind that if you want to use snapshots for a patching perspective or some sort of upgrade perspective. VMware has some cool features called vFlash Cache and vSAN. And actually, vSAN now can support FCIs are now supported in vSAN, but not the caching parts of the vSAN. So vSAN can do some caching to make your reads go faster because it keeps things closer to things. All the caching tools don't work well with failover cluster instances on VMware. And it adds more administrative work to the VMware admin. And you know what? The VMware admin will complain about it. But we all have things where we have constraints. We have vendors that happen to that say, hey, I got to have SA. No, you don't. We have to deal with those kinds of issues. Your VMware admins or your virtualization admins have to deal with the fact of if you need to do an FCI because you have the business rules to need to maintain a failover clusters while virtual, they will have to just work around it. They can have policies, but everything in IT, we all know, we all run into things that violate the IT policy because this is how it has to work. I don't have a lot of empathy for the VMware admins. Their life is pretty simple in a lot of areas that they try to make it sound complicated. It's really not. It works really great. And so having a few areas where things are difficult, that's okay. They're paid a lot of money as well. More VMware settings. So when you're doing things, VMware has a thing called DRS, which is, I forget, but basically in the day, it's Dynamic Resource Scheduler, I believe. What it means is if a host has too much going on it, it will look and see if I can move a virtual machine from this host to a different host with less CPU usage. That way we can guarantee better resources for the virtual machine. It will automatically move things around. You do not want DRS to automatically move your SQL servers around, especially the ones that are part of your failover cluster instance node. You really don't want to move in your AG nodes as well, but it's not critical here. You just don't want it happening. You also want to create anti-infinity rules. Both Hyper-V and VMware have the same thing. I forget what Hyper-V calls them. In VMware, they're called anti-infinity. Basically, it means do not ever run both nodes on the same physical host. Because if that physical host goes down, but the entire failover cluster instance goes down. You want to have them separated out. One on server A and one on server B. You never want them running on the same physical server. There are, when you format drives or format data stores inside of, or disks for a virtual machine, you have multiple different formats. There's thin, there's thick, and there's eager zero thick. What eager zero thick basically is kind of like the log file. Basically means when I create this data file for this virtual machine, I will write zeros to the entire size of that virtual machine disk file is going to be. So the zeros are already pre-written. This prevents any, so when growths happen, the growth can go very, very quickly. When I'm using an RDM, I don't have to do a lock process and cause problems. So the eager zero thick makes the performance a little bit better, and it's a requirement. You have to use eager zero thick. All RDMs should be on a separate SCSI controller. And you must use the LSI logic controller, not the para-virtual controller. If you read best practices, most people tell you the VMware para-virtual controller for your storage controllers is actually faster in the range of 10 to 30%, and it has less CPU impact. However, the RDM does not work very well with that. You need to use the LSI logic controller. And when you put your OS disks on the first controller, you want to create a second controller or a third controller and put your RDMs on that one, not using the same controller as your OS disk. In VMware, there's a thing called parentally reserved RDMs. This means when VMware reboots the host, it has to do a scan of all the possible data paths it can use. When you're using RDMs, that data path is locked to the virtual machine that has it, and the VMware via VMware software ESXi will sit and scan and wait for that path to be able to be scanned. It's locked. It can't scan it. It waits 60 seconds to a minute or 60 seconds or more to time out. If you've got 30 or 40 RDMs, you just added half an hour to your boot cycle. If you use a parentally reserved RDM, there's a KB here, follow that KB, and it will basically skip those. It goes, oh, those are RDMs, I know it, don't try to scan it, and just move on. So it cuts your reboot cycle down. This next bullet point is one that I debate taking out because this was definitely important in older versions. I don't think it's important anymore, but I haven't tested. What it says, talk about adding your additional SCSI controllers before adding your additional networking. VMware, it all came down to how the Windows OS and how VMware presents the PCI slots to the virtual machine, and when you did certain patching and or certain updates, how to renumerate the PCI bus numbers before things would work. And so you wanted to have your SCSI controllers in the lower bus numbers than the your network adapters on the higher ones. Mostly from the standpoint, if I had a network adapter, say I had controller 1, then I had controller 2, then network adapter 2, and then controller 3, and then I removed adapter 2, on the next possible update of certain things, I could have a rescan, and all of a sudden it'd renumber the PCI number for controller 3, and I'd have some interesting storage issues. It shouldn't happen anymore, but I left it in there because it just in case it does happen. And it's just the best practice, and it's one of those things, sometimes I don't like the change, and this worked in the past, and let's continue with the best practice from the past. Next bullet point, VMware HA should definitely be enabled. So all systems should have VMware HA enabled all the times. All the same best practices for your SQL Server exist in virtual as versus physical. So anything about your TIMDB, your model database, your cost threshold, your max stop, all those kind of best practices, they're absolutely the same. There's no difference if I'm physical or virtual. So make sure you still follow all the best practices for SQL Server. It is much more important than getting a lot of these things right. Example of DRS rules. So here's a DRS sample of it. Basically anti-infinity rule. I want to separate virtual machines because you can also have them to different options to keep them together. Here I want to separate. Hyper-V issues. So Hyper-V, basically same thing with DRS. I have performance resource optimization, which basically moves the VM back and forth kind of stuff. You want to prevent doing that. So you remove that. It's part of your system center. Separate anti-infinity rules as well to make sure you keep them apart. Make sure you're using VHDX drives, not VHD drives. The VHDX is, again, it's already zeroed out for faster controllers. Multiple controllers are great. Spread out the load using, so don't have just one controller for all 6, 7 drives. You might have 3 or 4 controllers. The amount of controllers is really more based upon how many drives you have and how much I/O you're really going to be pushing. If you're not pushing a lot of I/O, one controller is actually just fine. But anything that's big and important stuff that has lots of I/O on it, it should definitely have multiple controllers. It's easier to manage from a queue perspective, from the virtualization layer, and also from troubleshooting. And of course, the in-guest fiber channel works great on Hyper-V. So cluster settings. So Microsoft recommends increasing some timeouts for when you run SQL Server failover cluster instances on Hyper-V. VMware doesn't make the same statement, but you know what? If Microsoft is doing it, they're doing it for a reason. It comes down to how the networking layer works inside of a virtualization layer. And in fact, in 2016, or Windows Server 2016, not SQL Server 2016, Windows Server 2016, the recommendations for slowing things down was actually applied and is actually the defaults now. So it used to be the fast failover default, and so we talk about parameters, same subnet delay, and then cross subnet. So if I happen to be a stretch cluster, or if I'm doing an availability group where I have a DR node, that's cross subnet. It's on a different subnet. Same subnet, it's on all local to it. So the amount of heartbeats here will used to be 5 for fast, which was the default in 2012, is now 10 for the default in 2016, also called as the relaxed. So when you're virtual, you should be running at 10 heartbeats for your failover process detection. And then on cross subnet, you want to up it to 20 heartbeats, meaning in each heartbeat's 1 second. So it's 20 seconds before it can detect a failover, detect the system. It means it could be up to 20 seconds before they determine that the other node is down. And there's a nice little KB in here from Microsoft about it, where it's at your blog post. All right. One question I talk to people a lot nowadays is, do I still need a heartbeat network? Well, the answer is depends. Technically speaking, you don't need a heartbeat network, but when you go through the setup wizard, it's on the cluster setup, it's going to tell you, regardless if you're doing an AG or an FCI, that you need to have it. You're lacking redundancy on your networking side. The heartbeat is now sent out over all after 2008 R2 and beyond. The heartbeat is sent out over all active network connections. Meaning, if you have 2 network drive things in there, one's a heartbeat and one's your normal networking traffic, the heartbeat is sent out over both ones. And so which one responds first is the one that acknowledges it. So it doesn't matter if you actually have a heartbeat or not heartbeat, because you don't know which one is actually being used by the cluster to determine if the heartbeat's running or not. All virtual switches now. So when you're in the virtualization layer, you plug into your virtual NIC plugs into a virtual switch. It's all on the software side. You don't touch anything. It just happens. That virtual switch actually is now plugged into physical machines. So each one of those by design should have at least 2 physical network adapters, which is providing you the amount of redundancy on the physical network layer that the old physical failover cluster instances used to have 2 NICs to provide you redundancy more than anything else. So do you actually need it? No, there's no reason not to have. There's no reason to have it, but there's no reason not to have it either. There's no harm. It doesn't cause any issues, and many people want it there because that's just how they've always built them. So at the end of the day, if people have, you put it in if you want to, but you can skip it if you don't. It doesn't really matter. It's just one of the things we can talk about. What happens is people are concerned that if I only have 1 NIC and that NIC goes down, my system is offline. If I happen to have, if I put in a heartbeat network and the primary network goes down, the heartbeat network's still working. The other cluster node says, hey, that the failover cluster node A is still up and operational, but no network traffic is happening because the network is down. I'm still down. There's no real difference. I still have the same impact, except in the case where the heartbeat network stayed up and the virtual network for the regular network went down, I'm actually not doing a failover. So I actually probably at worse risk. But again, it doesn't really matter. The redundancy you need for the networking is done by the virtualization network layer at the virtual switch layer. And Hyper-V and VMware have the exact same processes on this. Availability groups. So I've talked about availability groups a lot already. At the end of the day, availability groups and VMware are complementary technologies. They work hand in hand with each other. This slide here is mostly talking about all the special things that you got to deal with when being virtual. So for me, an availability group actually blurs my line between my HA and DR because I have one solution that covers my HA solution and my DR solution all together, versus my failover cluster instance is typically used just for HA. Yes, you can use geo stretch clusters for a DR solution, but those are always been painful and nobody seems to like them, and I personally don't like them either. So to me, the availability group does everything I need for that. I will never do an geo cluster unless I need the customer app. I can't talk the customer out of it. To me, it brings the best of both worlds of my failover cluster instances and my mirroring together. And I have a failover cluster instance gives me the VIP, the virtual IP address, so I can move that back and forth. And I have 2 copies of my data, and I've got proper monitoring. One thing to be careful of is watch licensing. Microsoft used to state in 2012 licensing rules that you could do for every paid workload, you had a free workload. So if you happen to have a primary and a readable secondary at your main site, you could have 2 copies running at your DR site, licensed under SA, because they were free. In 2014 and above licensing, they changed it. You get 1 free workload or 1 free server per workload, and an availability group is considered 1 workload. So if you happen to have a 4-node availability group, 1 primary, 1's running read-only secondary, the other 2 secondaries you had, you still have to license 1 of those. So most cases now I see is we do an HA node. So 2 nodes at primary site and 1 node at the secondary site for DR. If you want to add a second node at DR so you can have a proper HA pair there, you've got 4 nodes, you're still paying for 3 of them now. So be careful your licensing and make sure you understand the rules on it. So the availability groups can use your VMFS and your VMDKs in VMware. No more needs for RDMs. It makes life so much simpler. Your VMware admins love not having RDMs, so this makes them happy when you want to go with availability groups. As you see, I use AlwaysOn my deck here because I didn't switch off the availability group apparently. I have a hard time with the whole naming convention I covered earlier in the beginning. But all rules for AGs that are physical still apply. Nothing really changes, except for the heartbeat connections, which is not an availability group setting, but a Windows clustering setting. And you still need my anti-infinity rules. So if I have 2 nodes, I got to make sure they don't run together. So here's a diagram, basically what an availability group looks like. As you see, I've got the primary node and it replicates my data synchronously to my secondary node and asynchronously to my DR node. They're both called secondaries, but one's simply a primary, one's a synchronous node, one's asynchronous. And determining if I want to go synchronous versus asynchronous is mostly around my speed of my network. To be in synchronous mode, I have to have a really fast network because I will slow down the application if I have a slow network when I'm in synchronous mode. DR considerations. Some of the cool things, virtualization adds all kinds of new tools for DR. And stop thinking of DR from a SQL Server perspective and start talking to your VMware admins about what cool things is. Because at the end of the day, a VM is just a collection of files. And I can migrate and synchronize that collection of files using SAN storage. I've got other tools out there like Zerto with VMware SRM. Microsoft has ASR. I can replicate these things all over the world in all kinds of different RPOs and RTO methods that I don't have when I'm physical. And these things can make the things, make my options for DR much easier. Do I need to have my database running at the DR site, or can I have it come up with the application server? Because the application server is not the DR site, so I have a database there but no application. And it's going to come down to business rules. Defining what your recovery points and your recovery times are will let you know, can you use these? And there are a multitude of different options. So make sure you open your eyes and stop and learn about those to determine, can I make my life easier and make the system simpler? Let's go ahead and make the operation, keep the SQL Server as simple as possible. Let's not add complexity. We have enough problems with bad developers on the day-to-day basis. We don't need to add configuration issues just because we want to have a complex system. If I can let my virtualization storage admins do my replication and I can trust them enough to make it work properly, why not make a simpler solution? Trust, of course, is a major factor. And so when you do DR stuff, you got to understand there's different methods for that. There's going to be crash consistent methods for your snapshot replication processes and backup consistent. So the difference basically is the short version is crash consistent is no different than how a failover cluster works today. The system went down, it had to spin up somewhere else, but it was actually a hard outage. It's like you walk to the back of the server and pull the plug out of it. Backup consistent, which basically means I'm doing a VSS quiesce, which will tend to do a IO pause for 1 to 3 seconds to do one of these, depends on configuration. It's going to be the same way as a reboot would work. So in other words, things are closed down properly, so I bring back up. I don't have to go through the redo and undo logs as much. And a big thing too with storage replication, each storage vendor has different terminology and different methods for making things work, but you need to ensure the logs and your data are fully in sync during snapshots. Some places have things called like consistency groups where I put them in the group and the snapshot happens to both of them. Others don't, and if I do a snapshot, I do the data snapshot 1 second in front of the log snapshot. When I try to bring it up or mount it up, you'll see I have an LSN mismatch error, and then the database is listed as suspect. Then now I have to go through all kinds of fun recovery tools. Yes, you can recover them, but it takes time. So if you do my snapshot replication, the storage replication, making sure that the things are in sync is the most critical process there. So the short version here for conclusion is best you can virtualize your SQL Server clusters. You definitely need to review your business rules because that's the biggest problem. And can you simplify your environment? Remove clustering. I spend more time talking to customers, talking them out of availability groups and clustering to simplify their environment because it makes their overall cost operations much, much easier. Use them if you need them. It comes down to your business rules, and the business rules are the drivers. So you need to work with your the management and senior management to determine what really are the business rules. From an RDM perspective, your storage decisions are your largest part of determining if I can do a failover cluster instances. Make sure you architect for your autonomicity, agility, performance, and scalability so it can work out properly. And these guidelines will help you make sure your FCIs or your availability groups work just fine. And any more questions, Tom?
Yes, I do. I have one more question here for you. Where should the file share be hosted?
Hold on, you're breaking up badly, Tom.
Am I breaking up badly? See if that gets better. Try again here. Is that better?
It's got a cool echo.
Oh, it's got a cool echo. Sorry. Let me mute it and go back on. Okay, is that any better?
No, but I can just struggle through. So say, I can understand you enough, I think.
Okay. Where should file share be hosted? Same as primary node or secondary node?
So where should the file share witness be located? My preferred answer actually is to put the file share witness on a SMB or a CIF share on your storage system. It should not be on the secondary or the primary, any of the SQL Server nodes. A lot of people put them on the file server somewhere or a Windows box somewhere else. Why I talk about putting on the storage directly is understanding how quorums work and dynamic quorums work. So if you have a 2-node availability group with a file share witness, and I choose to put, so I got a total of 3 votes, and I choose to put the file share witness on node 2. When node 2 is rebooted, the file share witness goes down along with the SQL Server instance. That's 2 of my 3 nodes. For a quorum to work, it needs to have a minimum of 2 nodes up or 2 votes. So what happens is node 1 thinks that the node is isolated, and it's at fault, so it shuts itself down. So if you put the file share witness on a SQL server and you do a reboot of that server, your cluster could shut down. Why I don't like putting it on the Windows server somewhere like your file share, file server inside of a Windows box somewhere is Patch Tuesday. Most organizations do a lot of automated patching. And if I'm automated patching my SQL server and my file server at the same time, there's a chance that both the file share witness could be rebooting at the same time my SQL server is rebooting. And again, 2 votes down, my cluster shuts down. Also not good. Versus your storage system. Yes, your storage system does go down. Should be less often and should never be in sync with Windows patching. It's still possible, but highly unlikely. So my favorite answer, of course, is I always ask the storage people, can they provide me an SMB share or a CIF share off the storage and use that? I must be able to properly apply window account permissions to that, that share. And some storage applications can provide me a CIF share, but I can't apply permissions to it properly, or I can't do AD authentication to it, because the computer accounts for the cluster, failover clustering from Windows, need to be able to address and change permissions on that share. And if they can't, then you can't use a storage-based file share witness. Any more questions, Tom? I see Tom's unmuted, but he's not talking properly. I'm guessing he's still having audio issues.
There
you are.
That's a little bit
There
better.
You go, Tom.
To be clear, in our environment, we have shared folder on our DB cluster environment, SQL Server 2000 R2 SP1. In Windows 2008 R2, DB and App Server are in different network zones. Our database is not able to mimic, let me see if I can get down to that, mimic setting up a shared folder, the same in SQL Server 2014 with AGs. Not sure what his question is there for us, Sean. Maybe.
Yeah, neither am I. I'm trying to figure out the different network zones. I'm missing a key piece of information for making it a question. I'm sorry. Was my email address listed? Actually, here. My email address is listed on the sales slide. Go ahead and email me the question, and I will see if I can answer it better.
Okay, I'll have him email it over to you. And anyway, we appreciate today for you coming and sharing your information about failover cluster instances. Always interesting to throw a little bit more complexity into the world for us, as we do. And this is being recorded, so we will put it up on YouTube by the weekend. And you can listen to it again. Someone wanted to slow it down a little bit for you, so
yeah, I cover a lot of material and I speak kind of fast, and I'm sorry about that. So yeah, you can go back and slow down and repeat a few things.
Yeah, he can do that. Sean, thanks again. I appreciate it, and we'll have you on a little bit later on. Hopefully not as long waiting as this time was, but
sure. Well, we're supposed to this in October, but we had to cancel due to the hurricane coming through my neighborhood.
Yep, exactly. So, all right. Thanks again, ladies and gentlemen, and have a great day.
Thanks all. Appreciate it.
Bye-bye.